Okay, hello everyone. In this video and the following video, we will be learning how to use nesting in combination with mapping to execute code across multiple data sets that are bundled together. Specifically, we will be performing individual statistical tests, specifically Townsend slope analyses across some time series data at a handful of different sites along the Colorado River for a handful of different water quality ions. So all of this data that we're going to be starting off with here is data that you produced in the one Tidying Water Quality Data RMD. So the first thing we're going to do here, after of course loading in all of our necessary packages, is load in that water quality object. So I'm going to call it WQ to follow along with the lesson plan here. We're going to use read RDS to load it in. This data should be stored in our data folder, and we should have named it tidied full WQ, I believe. Let's see if this works. As we've loaded in this data set, I actually want to immediately perform some simple tidying steps to subset this entire data set to just low flow months, and then get the annual median low flow value across all of the years at that site. So if you're following along with the lesson plan, I'm about to just create what we called the low flow object, I believe. Let's see here. Yes. So I am going to just copy and paste this chunk of code from the lesson plan in here. Essentially what I'm doing is I'm first, of course, using that water quality object that I'm creating two new columns, month and year, based on that date column that already exists in the water quality data set. Using that month column I just created, I'm filtering to only include in the western US, typically low flows occur in, and what we mean by that is literally when streams are at their lowest discharge. That typically occurs in late summer and early fall. So we're just filtering out, the months from late summer, August through 11 November. Then we're using the group by and summarize to identify for every site parameter combo the median value for every year in our data set. And then we're using this arrange function at the very bottom there to make sure that our data is ordered properly so that from one row to the next we are increasing in years. So I'm going to run that. Let's go ahead and look at it to make sure it looks the way I'm envisioning it to, and in fact it does. We have for every site and parameter combination across years that median value in that certain ions concentration. So with this data set, we want to answer the research question, is there a significant trend in concentrations through time during low flow periods for all of our sites and all of our parameters in this data set, right? So we have a handful. In other words, we want to perform our send slope test on however many combinations there are in this data set. We could do this in practically a zillion different ways, but today we will be using nesting and mapping. So this is the data set that contains all of our combinations, but let's just go through the motions of performing this send slope test on just one of these combos. And I am going to use the Dolores River and calcium as our example here. So I'm going to call this CA for calcium, Dolores, and what that's going to be is just a subset of our low flow data set. I'm going to filter so that our basin name equals Dolores and the parameter must equal calcium. Uh-oh. Maybe I got the name wrong. Let's look at Dolores again. Or just look at our low flow data. Maybe I got the name of the, no, parameter, calcium, basin. Let's look up the names in our data set here. Unique, low flow, basin. Oh, I spelled Dolores wrong. Classic. Okay, Dolores. Okay, we're back on track. So now we've got an object called CA Dolores. And just to clear things up here, I'm going to remove this misspelled object from my environment so we can pretend like I didn't do that. Beautiful. What we've got here is just a subset of our water quality data, essentially just at our USGS site along the Dolores River, calcium, the median concentration across years. So now we're going to perform the SENS slope analyses, which takes essentially the Mann-Kendall test a step further. The Mann-Kendall test is a non-parametric statistical test that you're able to use to detect whether or not a trend exists in time series data. So that would be helpful here, but we'd also like to know not only whether or not there's a trend, but the magnitude and direction of that trend, which is where SENS slope kind of has a bigger benefit, I guess, for our needs. So not only does it perform the Mann-Kendall test within this function, but also tells us whether or not that slope is positive, or the trend rather, whether or not it's negative. So we're going to use the SENS slope function, and I'm going to call the model output of this just Dolores trend. And then we're going to use that SENS slope function. The only thing that you need to provide it is an actual vector of all of our time series data. So if we look at our calcium Dolores, we've got this column of our information ordered by year. All we have to do is pull that in for SENS slope to work. So I'm going to do CA Dolores, $, and select that concentration column. So let's run that, and let's look at the output. If we just go ahead and view the output of this object, what you see here is a handful of information, but the two most useful bits of info from this test are the p-value, which we have here, which tells us whether or not our results are significant, and then the slope here at the bottom, which tells us the direction and magnitude of that trend. So if we're using an alpha of 0.05, clearly, really any alpha value of use, it's quite clear that there is not a significant trend found in the data set. So not super interesting here, but to move on, the other piece that I want to point out is the way that this data is stored is not particularly intuitive, I guess you could say. It's not very storage friendly. It's not super stackable. Let's say if we wanted to, which we will be doing, performing this SENS slope across multiple places, or places and parameters, we want to be able to kind of stack this information nicely. So to get around the bizarre structure of these models' results, we can use another function called tidy, which was designed to essentially deal with this issue of having model results very often stored in these ugly lists. And what tidy does is it pulls all of this information in this list and converts it into a single row of information, blech, and then it's structured it so it's structured as a data frame. So we are going to use the tidy function. I'm going to call it tidy Dolores, and I'm going to just use tidy and then give it the model results that we want to tidy up. Oop, spelled it wrong. And what we find now is something that is much prettier, much easier for us to play around with and manipulate in the future. Plot twist, very annoyingly, and I'm not sure why exactly, but this tidy function, if you remember, one of the biggest pieces of information for the send slope is the slope, is not included in this data frame. So we're going to need to tack that information on in a different way. And there's a couple of ways you can do that. But here I'm going to essentially create a new column. We'll call it slope. And we want to fill that column in with, and this is something you don't necessarily need to know off the bat, but here it's listing out all of the information contained in the list. We want to fill it with what we're calling our estimates, which is actually that send slope value. So now we've got the slope. As we can double check, they're the same. We did it right. But thinking about the future, we want to be able to do this across multiple site parameter combinations. So how about we convert all of this gunk into a single function? And I'm going to call this function the tidier sense. So the first thing is we're going to give it a name. We're going to make sure that it's a function. We're going to perform this function on our time series data. Here I'm just going to use the word data as a placeholder for future objects that we want to perform this function on. The very first step here is, let's call it the model. The model is going to be our sends slope functions output when performing send slope on our data set. Then we immediately want to tidy the results of that output. So we'll use the tidy function on our model. And then, much like the code up here, we're going to immediately tack on a slope column, which will be equal to the model outputs information stored in its estimates. Because this is the final object in our function, we don't need to technically use return, and instead the function will know that what we want as its output is the results of this kind of manipulation we're doing here. So let's test it out. I'm gonna run that. And I'm gonna just call this test case. What we want to do is run our tidier sends function on our time series data. So we're gonna replace data essentially when we run this model, or pardon me, run this function. We're gonna use our CA Dolores concentration data. So this test case should in theory look identical to this tidy Dolores, but let's see if that's the case. Yay! So using a function, we now have a tidy row containing our statistical results of running the send slope test on our Dolores calcium data. In the next video, we're going to use the code steps that we just outlined and developed, but across all of those parameter site combinations of our water quality data set using mapping and nesting. So stay tuned.